So in this question, which is question number 56, it has been said that we need to find out the sum of all natural numbers between 100 and 1000 which are divisible by 11. These are the various options which have been given. So before finding out the sum, we need to find out which natural numbers are divisible by 11 lie between 100 and 1000. And basically we need to find out which multiples of 11 lie between 100 and 1000. So now we know that 11 into 9 is basically 99, and then 11 into 10 is 101. 110. So basically we can say that after 100, the first multiple of 11, which is first number which is divisible by 11, is basically 110, which is 10 times the multiple of 10 times 11 is basically 110. And now we need to find out a number before 1000 which is also divisible by basically 11. Now we know that 990 is basically, it is divisible by 11. And now if we add another 11 to this, then this comes down to basically 1001. So 1001 is greater than 1000, and we are not considered with this number. We'll take the last number which is divisible by 11 is basically 990. So 990 will come somewhere around here. Now 990 is nothing but it is 11 into 90. So 11 into 10 is the first number, and 11 into 90 is the last number that we are considering. So therefore we can say that the numbers that are coming up is basically first number is 11 into 10, and then we'll have 11 into 11, then we'll have 11 into 12, and that will go on up till we'll have the number 11 into 90. So these are the numbers which lie between 100 and 1000 and are divisible by 11. So therefore the required sum will be basically equal to 11 into 10 plus 11 into 11 plus 11 into 12, and that will go on up till we have 11 into 90. So if we take 11 common, so we have 10 plus 11 plus 12, and it goes on up till 90. Okay, it goes on up till 90. So as you can see, we need to find out the sum of this sequence and then multiply it with 11, and we'll get the required summation. So now as you can see over here we have 11. The number of terms in this sequence, as you can see, is will be basically equal to 91. Not 91, 81 rather. So there are 81 terms. So 81 by 2, first term plus last term. This is the summation sequence that will be following over here. So this will be equal to 11 into 81 by 2 into 100. So this will divide and we'll get 50 over here. And finally we'll have 11 into then 5 and 4 for basically 4050 is the number that will come up with. So 11 into 4050 will be basically equal to 4050 into 11 will be equal to 4050, then another 4050. So ultimately we'll be coming up with the number 44550. So the required sum is 44550, and as you can see, that is available in option A. So option A over here is the correct option. So this is how you solve this question number 56 from the CSCPT question paper of year December 2017. We'll be solving the next questions in the subsequent videos. Thank you very much.